lagging.
Power factor is 0.8 lagging. 3-phase
Lagging.
and kV voltage is 33 kV. Voltage is, what is voltage? 33 kV.
So
If the
10,000
line
kilowatt means 10 megawatt.
10,000 kilowatt means 10 megawatt. Right. You are correct.
ठीक है.
You are correct. 10 megawatt. 10,000 kilowatt means 10 megawatt. Right. You are right. So the problem is that load is 10 kilowatt. 1,000 kilowatt, that is 10 megawatt. Power factor 0.8. 3-phase 33 kV. R equal to 5 ohm. Resistance XL equal to 10 ohm. Find kVA of synchronous condenser. Understand? So I want to know the synchronous condenser. We want to determine the synchronous condenser, capacity of the synchronous condenser. You know that the objective of using synchronous condenser is that the supply voltage and receiving in voltage together may be equal. Understand? Why we use this method of improving the voltage? That is, the supply voltage and receiving in voltage should be equal. This is our objective. You understand? You understand the problem?
Yes, sir.
So this message is from Mehta's book.
Yes, Mehta's book, page number 384. 384 is the page number. What is the objective of the problem? Objective is that our 33 kV is our supply voltage. So at the receiving end voltage, we must get 33 kV. This is our objective. So that because if we do not use synchronous condenser, then we will get, you may say 30 kV, 28 kV like that. What the calculation? That is less voltage we will come, but it is not desirable. So our objective to use the synchronous condenser is that we can get the exact voltage what we are sending. That is, we want to get the 33 kV at the receiving end. Receiving end means load side. I think you understand what is the use of synchronous condenser. Okay.
Sir.
Now we want to determine the size of that is rating of the synchronous condenser. We want to determine the figure will be like that. They told us to use a synchronous condenser so that both sides the voltage must be 33 kV here. You have to maintain 33 kV at both sides. It is a long distance. The supply may be 1,000 kilometers, the distance from load, long distance transmission line. Now I want to determine the size, that is kVA rating of the synchronous motor. So what can we do? We know the formula. But before that, I want to determine the current. We can determine the current. P equal to √3 VL IL cos theta. Yes, but if you tell in single phase, P equal to VI cos theta, it is correct.
Yes,
in single phase, because there is no line voltage, no phase voltage, nothing else. In single phase, it is only the phase voltage. So you can say P equal to VI cos theta. But in case of three phase, we must have to tell that V is whether it is line voltage or phase voltage. We have to tell. That is why P equal to √3 VL IL cos phi or cos theta, whatever. Okay, VL is the line voltage, IL is the line current. Yes, it is a three-phase system. It is a three-phase system, and you know that alternator always alternator or load generally star connected. That is IL equal to, for a star connected, IL equal to IP, but VL equal to √3 VP. We know the formula, but here we can write IL equal to IL.
Sir, you wrote 2IL here. It should be a P 3 √3 VL cos.
Okay, good. Thank you very much. √3 VL cos phi. So 10,000 into 10 to the power 3. √3 VL is 33 kV into 10 to the 3 into 0.8. The result is coming.
So 218.6.
Oh, let us say 218 ampere. It has come by calculation. Okay. Now you see what is IP. Wait, that day we deduced the formula IP. The IP means what? And IQ is the quadrature current, and IP is the phase current. What will be the result?
So from where it comes? IP is equal to IL cos theta.
IP equal to IL was a last year deduction. You see in the notebook the deduction. Okay. IP equal to IL cos theta and ID equal to IQ equal to IL sin theta. Well, from vector diagram.
Every current have IP and IQ.
Yes. Understand in the vector diagram. Article number 15.11. Article number 15.11. We from vector diagram we have calculated all these things.
Yes, sir.
Last class. Good. So now it will be coming. Okay, you understand from the vector diagram. That is cos component, cos phi. The vector of the understand? Okay.
Yes,
from
sir.
vector diagram, you see a portion of the vector diagram I have drawn. The current side, the current portion I have drawn. Now IQ equal to what is the current? What will be IQ equal to IL sin? That is IQ, you see IQ was the quadrature current. And ID, there is total current I2, you can write it I2. You can write it I2. I2 equal to sum of the two current, IP and IQ. Now, the two components of current we have determined. IP equal to IL cos phi.
So 218 into 0.6 is equal to 130.8.
130.
0.8.
Okay, correct. What is coming in your calculation? Okay. 130.8.
Okay, sir.
Now we
Yes, sir.
the sending in voltage. Now you here we may wrong here. We may be doing wrong in performing that calculation. There is 33 kV. Anybody can ask me, what is that voltage? It is your phase voltage or it is line voltage? What is that voltage? Phase or line? What you can tell?
Sir, if they are not mentioning, so it would be line voltage.
Oh, thank you. I told on the first classes. And you know from earlier days, that if anything is not told, we must think that it is line voltage. It's okay. So we 33 kV must be the line voltage. So the formula we know for a star connection. What do you know? VL equal to root 3 VP. VL equal to root 3 VP. So we can write VP equal to VL by root 3. Okay. What will be? by root 3. You divide
19.05.
19.05. 19.05.
One question, sir.
Yes, sir.
Say here IQ equals to IL sin phi, sir. The value of phi is 0.6, sir. From where you get the 0.6, sir?
You see, hello.
Thank you,
Sin
sir.
square, or there are many ways, or you can convert. It is a lengthy process. If you convert cos theta equal to what? 0.8. So theta equal to cos inverse 0.8 equal to 36 degree. So cos 30 sin 36 degree equal to 0.6. Can you? Another way is there. I am telling you another way. Cos inverse 8.8 what?
36.87. Zero 0.6, yes, sir.
Okay. So sin phi, theta or phi is the same phase angle. Understand? In that way, you can also find out 0.6. We are going ahead. So yeah, now the sending in voltage is 19.05. So our receiving in voltage should be 19.05. It is our objective. That is objective is sending in voltage equal to what will be the receiving in voltage. This is our objective. So for that cause to make VP line that is VP equal to that is the sending in voltage actually. How can we do this? How can we do this? VS equal to VP equal to 19.05. So our receiving in voltage what it should be? Sending in voltage is 19.05. What will be the
Receiving in same, sir.
Same. Good. Thank you. Same. That is our objective. We can do it same because we are using synchronous motor.
Yes, sir.
For improving the power factor and voltage. Understand? So the formula we can use, you know the formula. What was the formula that day we derived? Vs square equal to what? V2 square. V1 square equal to you see the equation. What I am writing in your notebook, the equation is there. That is V2 IPR minus IM minus IQ. It will be IQ.
U.
Minus IQR.
Im minus iq into x, sir. X.
Good. You are giving attention. Thank you very much.
X then whole square.
Good. Thank you very much. Because in the last class we have computed all these things. And after that, IPX, RPX, yeah,
Im minus iq into r whole square.
yes, that equation we got from the vector diagram. Okay. The name is nothing. You can tell it V1. V1 means, E means sending in voltage. Understand? Induced voltage.
Sir, in this circuit, where is E1?
E1, yeah, or you can write it VS. VS sending in voltage.
Okay, sir. Okay, sir.
And name is nothing. Name you can give E1, VS, V1. V1 you can also give. V1 means what we are sending, and V2 means what we are receiving. V2 means what we are receiving. So V2, all those things are plus because the voltage drop that has to be improved. That voltage is added with V2. Now you put the what is our objective? We want to determine IM. You have to calculate IM. You have to calculate IM from the equation. So give the value in the equation. IP, what is the value of IP? 174.4 into value of R is 5 ohm plus IQ. What is the value of IQ? you see whether there is any wrong in putting the values. By calculation, the IM is found out 231. It is a simple calculation, you can find it.
Oh.
What will be the rating of the synchronous condenser? You see 3 into 12 into 5 m divided by and we are dividing by 1000 mint, it is kVA. So we can write what we can write the 3 into 90.05 into what is the value of IM? IM is 230.
231.
1 kilo. You see, here you understand